Alright, in this podcast we're going to talk about dilutions and then do some practice problems for molarity and dilutions. So if I'm diluting a stock solution, now stock solution is called a stock solution because I might have it in my stock room. So if I need a 0.1 molar of something, and I often will be easier for me to find something in my stock room that's 1 molar and dilute it than it is to start with a solid. So if I start with my stock solution, that is the concentrated solution, and I add water to it, this is what I get. Okay, so I want you to think about how does the number of moles of the solute compare in the two containers. Okay, well, you probably see that they are the same. If I count the number of particles, 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6, I have the same number of particles, which could represent moles, before dilution and after dilution. So it's key to understand that because, therefore, the moles of the concentrated solution is equal to the moles of the dilute solution. Now we also know molarity is moles over liters, right? So we know that I can replace this with molarity of the concentrated times the liters of the concentrated equals the molarity of the dilute times the liters of the dilute. Now, I can also make this a little more generic. Molarity of the concentrated times the volume in any units of the concentrated is equal to molarity of the dilute times the volume of the dilute. As long as these units are the same, they don't have to be liters. So why is that? So let's say in both cases, let's say I have 10 molar of, and I have 2 milliliters of it, and I am diluting it to 1 molar, and I get 20 milliliters of the dilute solution. If I take that 10 molar and I multiply it times, if I change this to liters, I'm going to divide it by 1,000 milliliters per liter. I do that on both sides. And kind of scrunch this in here, but I'm hoping you'll see the point that in both cases, on both sides of the equal sign, I'm dividing by 1,000. Okay? So therefore I can use milliliters on both sides. It doesn't have to be liters when I'm using the dilution formula. So this is known as the dilution formula. MCVC equals MdVd, concentrated and dilute. Doesn't matter what the volume units are as long as they're the same on both sides. Okay. So here's what I would do. So here I am preparing 3 liters, so I'm going to use a 3-liter volumetric flask. Oops. And I want 0.5 molar calcium chloride, and I'm using 10 molar of the stock solution. Okay, so I set up my formula, M1V1 equals M2V2. I'm using 1s and 2s instead of concentrated and dilutes, that's fine. And here I am trying to solve for, I'm trying to figure out, when you're doing a dilution, you're trying to figure out how much of the concentrated solution you need. So in this case, I'm figuring out how much I need, and it's 0.15 liters. So I'm going to add that to my volumetric flask, and then I'm going to add distilled water until I get up to the line. Okay, I'm making a total of 3 liters. I'm using a 3-liter flask. Okay, and we're going to do these dilutions in class 2 the first week or 2 of school. Alright, so let's take a look at this problem. So I have 15 milliliters of a 1.5 molar magnesium chloride diluted to a final volume of 200 milliliters. So what is the concentration of chloride ions in the final solution? Okay, so let's start off by doing M1V1 equals M2V2. Alright, so this is my concentrated solution, right? I'm diluting it, so I have 1.5 molar, and I can write that as moles per liter, times 15 milliliters equals I'm trying to find the molarity, the new molarity, and my new volume here is 200 milliliters. Okay? Alright, and this is magnesium chloride, and I'm looking for the concentration of chloride ion. So I'm first going to find the concentration of magnesium chloride. So M2 is going to be 1.5 times 15 milliliters over 200 milliliters, and you'll see the milliliters will cancel out. And whatever I get here, which is 0.1125 molar magnesium chloride, I'm going to take that, and what I know is that for every 1 molar of magnesium chloride, I'm going to get 2 moles, or 2 molar, of chloride ions. So I'm going to double that, and I'm going to get 0.225 molar chloride minus. I want a 3 sig figs because that's what I have in my problem. Okay? I'm going to talk a little bit about how to use stoichiometry, how to use molarity and stoichiometry, and this is the one area that students struggle the most with coming into class, is using things that you're given molarity for in your conversions. Okay, so the important thing to remember here, molarity is moles over liters, so moles, which is N, is molarity times liters. Okay, so don't forget that, it's very useful. Alright, so here's a no calculator problem. So it's what volume of 0.5 molar sodium sulfate will completely react with 500 milliliters of 0.2 molar barium chloride. Alright, so I'm going to write the equation. When you're talking about how much of something required to react with something else, you need a equation. So that's sodium sulfate. This is barium chloride, right? And when they mix, I'm going to get barium sulfate and 2 sodium chloride. So it's important for me to know that I've got a 1 here and a 1 here. So I'm just going to write I have 0.5 moles per liter, and I'm trying to find liters, right? And here I have 0.2 moles per liter, and I have 0.5 liters. Okay? So, if you remember, moles is molarity times liters. So 0.5 x is equal to 0.2 times 0.5. Well, I think it's obvious here that x is 0.2. Okay? So I need 0.2, and because this is liters, I need 0.2 liters. Okay, or 200 milliliters. Alright, I know this isn't in your packet, but let's see how we do. If I have iron 2 nitrate, dissolves in water, what particles are present in the solution? So FeNO3, 2, I put it in water, and what I get is I get an Fe plus 2 plus 2 nitrates. Okay? So, I don't get this. I don't have that. I have an Fe plus 2. So, it's important here to recognize you got charged particles. Okay? How about this one? Lead nitrate and potassium iodide react, gives you the products, lead iodide and potassium nitrate. What is the observable evidence that the above reaction occurs? So here's our choices. An explosion occurs. Well, I don't have any information that tells me that's going to happen. Does a gas form? Well, I don't recognize either of these things as gases. Does the solution boil? I don't have any information that tells me that. But a solid form, so I can look at this and say, you know, potassium nitrate is going to be soluble, but lead iodide, if I remember my solubility rules, it is going to be a solid, so it's going to be that. Alright, so let's take a look. No calculator. how many milliliters of 6 molar sodium chloride are needed to make 250 milliliters of 0.5 molar sodium chloride? So let's look at our answers. They range quite a bit. Here I've got two relatively small numbers. I got 500 and I got 3,000. So I have to get close enough to be able to decide which of these is correct. So how many milliliters of 6? So this is the dilution. M1V1 equals M2V2. And I have 6 molar of this times, and I'm trying to find volume, right? Times molarity of my diluted is 0.5, and my volume here is 250 milliliters. Okay? So my volume is going to be 0.5 times 250 over 6. Okay, so here's how I'd approach this one. Here's a 0.5, and this is 250. I can move this decimal place one place here if I move this decimal place one way or the other, one place to the left. Okay, so I end up with 5 times 25 over 6, or a little bit less than 1 times, this is a little bit less than 1 times 25. So my answer here is going to be 20.8. And we're going to stop right there.